Refreshing. So in society today, everyone wants to have the most. The most number of houses, the most number of cars, the most clothing, jewelry, the list goes on and on. Well, one thing that people don't think of that actually everyone wants to have the most of is water and clean water. And how many people out here think that we have a ton of water in the world? Well, I hope that I see everyone's hands in the audience up because we have a ton of water. Actually, we have this figure of number of gallons of water in the world. However, 98% of that water is in the oceans. So only 2% of our water is in freshwater sources, and that is that number. Of that 2%, however, 1.6% of the entire world's water source is trapped in the glaciers and the ice caps, and 0.36% is trapped in underground wells and aquifers. So that leaves us with 0.036% of the entire world's water source, which is equivalent to this number of gallons for this number of people, which is growing and changing at a very rapid rate.
Many people think that water is a renewable resource, when in fact we're using up fresh water so fast that the nature can't replenish it. Water is actually a finite resource. Because of this, there's an apparent need to get clean water and conserve it, but we want to take this a step further. Besides just getting clean water to survive, we kind of want to use clean water to solve many of the world's problems. Let's think about this. There's a huge gap between first world countries and third world countries. What does the United States have that third world countries don't have? Let's look at third world Africa countries. What do they have? Poverty, violence, and more disease. But where does this disease come from?
So, this disease is coming from water. Deaths from waterborne illnesses kill more people each year than any form of violence, including war. In fact, there are 30,000 deaths each week in Africa from waterborne illness, and 90% of these deaths are in children under the ages of 5. There is a very, very, very low chance that a mother will not lose a child. So, most of the women in these third world countries and these refugee camps and societies in Africa, it is their job to walk miles and miles each day to get water. And while they are walking distances to carry gallons and gallons of water back, which is very heavy, they are exhausted and they are attacked and sexually assaulted. And that's where most of the violence and assault comes from and occurs during this time period where they are walking or carrying clean water to try and bring it back to their children. So the problem lies not with trying to get a third world country to become a modern society and a country, but how can people focus on trying to become a modern society when they are spending all of their time just trying to get clean water or try not to be sexually assaulted. In fact, third world countries in Africa and people living there spend 40 billion hours each year walking to get clean water.
My name is Lydia Wilmer, and I'm an industrial engineer here at Georgia Tech. Industrial engineers have to optimize complex systems. We have to be able to save money for companies and be able to improve their systems and try to find a product that will do all of this. So with the whole water problem, I can help implement a product that will help solve this problem. Shannon, my colleague here, is an environmental engineer at Georgia Tech. She has to use her engineering skills to be able to solve problems within the environment. She helps try to solve problems with environmental hazards, and the dirty water is a huge environmental hazard. There are two different ways to be able to solve the water problem. The first way is try to get clean water and transport it to different areas, and this is kind of like a plumbing sort of thing that we have here in the United States. The other way we could solve this problem is by transforming the dirty water into clean water. The best solution would be transforming the dirty water into clean water. You take a look at this refugee camp here, you can see the dirty water of Africa. Some people drink out of it and they get illnesses and diseases, but even if you don't drink out of it, those illnesses can still get in you. And they can use, instead of traveling so far away to get the clean water, which they do, they travel so far, they could be using that time spent trying to get an education, trying to care for their kids, trying to get their kids to have an education. All things we have here in the United States that we can take for granted.
Okay, so we have access to clean water here, and obviously we've established that people have water there but don't have clean access to it. So what we need to do is find a way to take this water and constantly be transforming it to make it clean. So this is where Lydia and I asked ourselves, how can we do this and put our engineering skills to the test? We also watched a previous TED Talk by Michael Pritchard where he introduced the idea of a bottle similar to this Brita water bottle that I was drinking out of at the beginning, where the water is filtered as you drink and it runs through, so then people could use any water and fill up their water bottles. However, the problem with this kind of water bottle is that while it can work on a small scale for one person or maybe even support a family, there is so many people that need clean water that this just isn't enough. So we need to make this idea large scale. So looking back at our refugee camp, we see that this is our source of water here. So we took this image and we also looked at an image of how water purification happens basically, like in a reservoir. So in this system, you have a reservoir, you have the flocculation tank, the sludge collector, the filtration, the filtered stored water, and then it's run back out into distribution. So the most important things about this diagram are the flocculation tank, the sludge collector, and the filtration. And these three things are important because this is what actually gets the water clean. And if we could apply this kind of invention or type of reservoir water cleaning process to that picture of the stream that we saw in the refugee camp in Africa, then we could have large-scale water being cleaned and the villages would be able to sustain themselves around that. So we kind of looked at an idea like this, where this would be the flocculation tank with the water running through it, which would then filter through a filter and then come out with sludge in the sludge tank, which could be stored and then eventually taken away. So we looked for common items that we could build such a type of invention around. And we found that the best way to filter water would be, or flocculate the water through so that it keeps flowing, would be through an old-fashioned 19th century water mill, which we could then run through a filter, which could filter out the sludge and put it in a drum that would not be biodegradable so it could hold all of the sludge and then take it away. So with the mill that we were using, it's actually a very easy thing to construct, and that actually takes it a step back to a mill that would be used in the 19th century, which is a very interesting concept because through progressing we're actually going back to something from an earlier time, so then we can build progress for the future society as well.